Personal visualization, which focuses on visualizing data for the masses in personal context, has been a recent research surge. Recent advances in mobile augmented reality techniques shed new light on personal visualization for their advantages of fitting visualization within personal routines and arousing user interests. However, empowering general users to create data visualization in mobile augmented reality environments is challenging given a lack of tools that allow in situ design while supporting the binding of data to AR contents. We design and implement Marvist, a mobile authoring tool leverages context information to assist general users in efficiently authoring creativity or glyph-based visualization. With Marvist, general users without visualization expertise can bind data to real-world objects to create expressive AR visualization rapidly and effortlessly, reshaping the representation of the real world with data. Marvist adopts a bottom-up strategy to create visualizations. The pipeline mainly consists of glyphs mapping, visual mapping, and object laying out. Marvist starts at the glyphs mapping scene. Users can specify the mappings from data points to virtual glyphs, then enter the AR view. In the AR view, users can specify the visual mappings of data attributes and visual channels. Marvist objectify data attributes and visual channels as interactive beads that can be directly manipulated. With the visual mapping palette, users can easily create, modify, and delete visual mappings. When users modify the visual mappings, Marvist will automatically propagate the mapping to all objects. After finishing the visual mapping, users can further specify the layout of virtual objects in the AR environments. It provides both 2D and 3D interactions to help users edit and properly lay out their AR visualizations. Based on object detection techniques, Marvist allows users to synchronize the visual channels of virtual objects with those of real objects in one step to improve the efficiency. Furthermore, by creating mappings between virtual glyphs and real objects, Marvist can automatically place virtual glyphs with their physical reference. Bob, a travel and history enthusiast, goes to a museum in the last day of his travel in Russia. An infographic map depicting the path of Napoleon's march to Moscow attracts Bob's attention. He wants to visualize his travel route on the map for comparison and sense the history. Let's take a look how Marvist helps Bob create his perfect visualization. First, Bob imports his traveling data into Marvist. He decides to use the shoes, the house, and the money stack models to represent the routes, hotels, and daily expenses data respectively. After entering the AR environment, Marvist automatically duplicates the corresponding models for each data point, distributing them methodically on the map. Then, Bob taps on a shoes to open the palette for data bindings. Marvist recommends the length channels for him based on the ordered data type of the distance attribute. He follows this hint and uses the length channel to encode the distance attribute. Then he further encode the cost attribute of hotel using the height channel. Marvist propagates the same kind of binding to all data points that have the same attribute. So all the money stacks which also have the cost attribute are encoded with the height channel as well. Next, Bob decides to encode the rank attribute of the houses using width channel. Given the height channel of houses has already been used for visualizing the cost attribute, which may lead to an interference with width, Marvist sends a warning message to notify Bob of these pitfalls. Thus, he instead uses the color channel to encode the rank. Marvist automatically selects a suite of colors distinguished from the background color of the map, to reveal houses with different ranks. After finishing all encoding settings, Bob starts to lay out the virtual objects. First, he drags the houses to their cities on the map one by one using 2D sketching mode. Since the money stack models have the same layout as houses, Bob invokes the copy layout function to transfer the layout of houses to the money stacks collection, thus distributing the money stacks alongside corresponding houses quickly. Now he can easily compare the hotel cost and expenses every day. Time to connect the dots. Bob selects the shoes collection and trigger the layout sketch function to portray the travel itinerary on the map passing those hotels. He discovers that his path is similar to that of Napoleon's retreat from Moscow. Alice, an astronomy teacher, wants to visualize the volume comparison among Earth, Jupiter, and Neptune using a ping-pong ball as a benchmark for familiarity and intuition. Based on the basic interaction, Alice needs to manually adjust the volume of the Earth. Marvist provide advanced methods to detect and extract visual channels value of real objects, like width, height, and volume. Alice can directly assign the volume of the ping-pong ball to the Earth. Marvis will automatically propagate this new visual scale to all virtual objects with the same visual mapping. Carlos, a programmer, plans to present his typing behavior on his keyboard using Marvis. He doesn't want to move the virtual bars onto each keycaps one by one, which is quite tedious. Therefore, after successfully detecting and extracting the visual features of keycaps, Carlos create a mapping between the text of each keycaps and the text attribute of each data points. Marvis then automatically place each virtual bar to its corresponding keycaps, helping Carlos create the design with less workload.